Hello everyone, welcome back to Chapter 13 of the TRO text. This is Dr. Rhonda Kofelt. This is part 2. And what we're going to be focusing on in this part are your unsaturated, saturated, and supersaturated solutions. So the solubility limit is basically how much solute you can get to solubilize in the solvent. And so if you have it to that point where it's in dynamic equilibrium, where it's going back and forth, okay, and it's much as solute that can go in there, that is said to be saturated. If you add any more solute to it, it won't dissolve, and you will see solids in there. So the saturation concentration, obviously, as I said earlier, depends on temperature. So I can literally increase the temperature and get more solute to go into that solvent. Now, it may or may not stay when I decrease the temperature again. Okay? A solution that has less solute than it can actually hold, okay, or solubilize, is unsaturated. So if I add more solute, it will continue to dissolve at whatever temperature you are. If a solution has more solute than saturation says it should be able to hold, but it's still in solution, that is called supersaturated. And so a lot of times what we can do is we can raise the temperature and we can get more to go in there. I always think of sweet tea, because if you add the sugar while the tea mixture is warm, the sugar will dissolve. If it's cold, it won't. And so if you do that, then you can make more sugar dissolve in there. And then when you reduce the temperature, it actually stays pretty well. Some types of salts, though, if you do this, okay, you've heated it up or whatever, you've gotten more solute to go into solution than it should. You can literally just touch it and those solids will just come out, okay, and this is the end result. And so that was a super saturated solution where you had more than it technically should hold, and then some trauma will make it crystallize. This is what you see in the crystal gardens. I kind of alluded to that a little bit in chapter 12 when we talked about crystals. This is how you get crystals growing in your little crystal world, okay? Go to the toy store or whatever, or toy department at Walmart, and pick up a crystal garden sometime. If you've got kids, they will absolutely love it. And you seed it with one particle, and then all of a sudden, you're going to see this growth of crystals. Now, it may not be instantaneous. It may take a few days, but it's a really cool process. And so as that stuff comes out of solution, it will just form on that crystal. So that comes from a super saturated solution. All right, so this affects solubility, as we said, okay? Now, I like this example here because we all are familiar with vitamins, okay, and some of us take vitamins, and if you've ever had a nutrition course or nursing course or something like that, you know that some vitamins are fat soluble and some vitamins are water soluble, and the ones that are water soluble dissolve in our body fluids, and whatever we don't use that day, it goes out. Okay, so you can't really overconsume water-soluble vitamins very easily because you don't store them. Fat-soluble vitamins, on the other hand, can accumulate in fatty tissue because they're fat-soluble. And so if you take a lot of fat-soluble vitamins, then you can actually get something called vitaminosis. Okay, hypervitaminosis. And that can be very dangerous. Okay. The other interesting thing is people that get bariatric surgery or have a severe weight loss very quickly. If you've had fat-soluble vitamins and other toxins stored in your fat, as your fat gives way and dissolves, those toxins come out. And so that's why a lot of times people that are losing weight quickly get sick. They don't feel good because those toxins are coming out that had been stored in the fatty tissue. So what we're going to do is we're going to look at these vitamins and we're going to decide, are they going to be water soluble or are they going to be fat soluble? So let's remember, number one, we have to have, if it's going to be water soluble, It has to be an ionic solid or whatever, or it has to be polar, right? Now, these are some big honking molecules right here, and so I'm going to have to really look. And this is just a little glimpse into organic chemistry for those of you who are going to have to go on and do that after Chem 2. So when you look at these, you're thinking, okay, is this polar or not polar? Well, it's got to have some ability to do dipole-dipole interactions, right? So if you have, and with each other, okay? So if you have OHs, okay, that looks like water, right? Because it has an OH. And there's an OH here. That's the only one I see on that one. And then there's an OH here and an OH here. And I don't see any OHs on vitamin K. So knowing that it should be like water and it's not like water, which of these could we say for sure is not going to be water soluble? Vitamin K, right? Vitamin K, because it doesn't have anything to hydrogen bond with. Okay? Doesn't have anything to hydrogen bond with. Now, vitamin A has a really long chain of things that aren't going to be interacting with water in one little OH. So I'd say for all intents and purposes, it's probably not very water soluble. Vitamin C, however, is very water soluble, as vitamin B5. Okay, and so I have a little bit more explanation. Okay, it's highly polar because it likes hydrogen bonds. Obviously, we said K3 is not water soluble. It's fat soluble because it's not water soluble. Since the bonding here we said was, I forgot which one it was, A, it only has that one little OH. It's not gonna be very water soluble at all. So it's primarily going to be fat soluble, and we'll be able to store in the fat tissue. And then B5 is going to be water soluble because not only does it have the OHs, it also has the nitrogen hydrogen. So if you look for hydrogen bondings, that's in big organic molecules, that's going to be your clue as to whether or not they're going to be water soluble. And then you have some practice ones that it's asking you, is it going to be soluble in hexane? And hexane is just a bunch of C's, 1, 2, 3, 4, 5, and H's, okay? So right off the bat, we know this thing is not polar, okay? So if it's not polar, then only non-polar things will be soluble in it. So, and then I got them kind of drawn out for you so you can look at them. Okay, so that is how we're looking at solubility of the solute and the solvent, and how we define saturated, unsaturated, and supersaturated.